we have one page left from Chapter 6. It's just one separate type of calculation that we can do. It's called mass percent composition. And it answers the question about what percent of a compound's total mass would come from each individual element. So it's a question that can be set up without any numbers, right? If you were just given a formula like calcium phosphate there, Ca3PO4 parentheses 2, you could be asked what is the mass percent of phosphorus in calcium phosphate. So a couple of steps in this calculation. We first have to do the molar mass of calcium phosphate, but we're going to actually write it out this time and sort of show our work. So we need calcium, we need phosphorus, we need oxygen. There are 3 calciums, and calcium from the periodic table is 40.08. Okay. And how many phosphorus are there in the formula here? 2, and that's 30.97. And how many O? How many O atoms are in that formula? There are 8, because 4 in phosphate, but there are 2 phosphate groups. So there are 8 O's. Okay. So that's what you would do for the molar mass, right? Why don't you get your calculators out? Here's my bucket of calculators. So it's just normal way of doing molar mass. We just sort of wrote it out because we're going to have to go back and look at one of these. But if we sum those up, somebody get a total? Give me a second. What did somebody get? 310? 310 point what? 1.8? Yep. Okay. What is the units of molar mass? Atoms? Nope. Not quite. That would be Avogadro's number. It would be Avogadro's number of atoms in something. What's molar mass? What is that? Grams, yep, and it's grams per mole. So anytime we're just talking about just molar mass, that's grams per mole. Okay, that is the molar mass of calcium phosphate. Okay, well, remember how to do that. So this question should be a fairly easy one then. What is the mass of 1 mole of calcium phosphate? Easy question. Sometimes the questions can be easy. Look at what we just wrote down, 310.18 grams per mole. So what is the mass of 1 mole of calcium phosphate? Okay, that's what molar mass is by definition. Okay. So 310.18 is the number of grams per 1 mole of that compound of calcium phosphate. Our question, though, is what is the mass percent of phosphorus in calcium phosphate? So if I know the mass of 1 mole of the whole compound, now what I need to know is the mass of just phosphorus in 1 mole of that compound. Okay? So would it be 30.97? That would be if it was just 1 phosphorus in the formula. But since there are 2 phosphoruses in the formula, we have to do this. The reason we sort of wrote out the molar mass is because right there, in 1 mole of calcium phosphate, we would do 2 times 30.97. Okay? That's 61.94 grams phosphorus. Okay. It's just a little shortcut basing it just off of the molar mass calculation that we can do. Okay. So again, the question was, of the mass of calcium phosphate, okay, of the total mass of a calcium phosphate sample, what percent of that mass comes from just phosphorus? And to do that, we have to just arbitrarily say, okay, we're going to have 1 mole of this substance. We know what the mass of 1 mole of that total substance is, because that's just molar mass. Okay? And if I had 1 mole of that substance, we also know what mass of phosphorus that would have, because that's the phosphorus component of the molar mass. See how that works? So then all you have to do for mass percent, we'll do percents a couple of times in this class, but anytime it's a percent, it's just a, if it's a mass percent, it's a portion, a mass of a portion of it divided by the total mass. Okay? So for us, we would do 61.94 grams, because that was just the phosphorus, and we would divide it by what? Okay. And if you just divided like that, you would get a fraction of 1, right? You would get 0 point something. What do you have to do to turn a fraction out of 1 into a percent? Yep, we're just going to multiply by 100. In this case, the percent sign is just a unit. So unless you really know how to use it, don't use the percent key on your calculator. Just do times 100 and use that percent unit, because those units are the same. They'll cancel. Okay. How many significant figures would this answer have? Yep, 100 is exact. We'd be limited by 4 sig figs. There's 5 down there. Okay. So what did somebody get for this one? Everybody get 19.97%? Okay. Hopefully that should not be too bad. And if you just look at how molar mass is calculated, okay, you should be able to see that the phosphorus would be about 20% of the total, right? We had 3 calciums, 2 phosphorus, 8 oxygens. You just take the mass of the one element multiplied by whatever its subscript was, okay, to give you the right number of them, okay, but then divided by the total molar mass. Okay? So these ones are, you can do these ones for practice. I'll put the answers in the notes here. I want you to try this one right now. I want to know what the percent of sodium is in Na2S, sodium sulfide. Okay. So make a fraction, multiply it by 100%, and we'll see if we can do it. So do sort of like we did before, write out how you do the molar mass. That will remind you of what you need to do for the element that we're looking for. So those were the components of the molar mass, right? What did you put up on the top of your fraction then? 22.99? Close. Yeah, you have to take, because there are 2 sodiums in this formula, you have to use that component of the molar mass. Okay? So you have to do 2 times 22.99, so it should be 45.98. Because we're asking, out of this formula, what percent of the mass comes from sodium? And if there are 2 sodiums in the formula, you have to account for that, just like you would in the molar mass. Right? So then divided by 78.05 grams. Okay. So then what's the percent that you get from this? What did you get? Somebody can say it. Thank you. 58.91%. If you have 4 sig figs, you can do it that way. Since there's no other numbers in here, just the sig figs that come from your masses will just be what limits your answer. Okay. So anybody have any questions about that? You should be able to just practice that a couple of times. Really, if you practice that with sodium chloride and sodium bromide or something like that, you'll be good with that. Okay? But that's an extra little, just a little separate problem. It's a calculation that that fertilizer manufacturers have to do all the time, because any kind of fertilizer that you'll buy has mass percentages of nitrogen, phosphorus, and potassium, or whatever the elements are on there. So if you're low on phosphorus or something, you use a fertilizer that has a higher phosphorus percent. Okay? But it's exactly that kind of calculation. They do that calculation with the particular compounds that they use, because they don't have pure nitrogen or pure phosphorus or anything like that in there. It's part of compounds. So they've just figured out the mass percent for you, and that's what those numbers end up being. Alrighty.